Hello, this is area and circumference of circles. Let's fill in the formulas for the area. Area of a circle is found by taking pi times radius squared. Circumference is 2 pi r. In other words, you could also use the diameter times pi because the diameter is 2 times r. So let's try an example. Here's a circle with a radius of 7. To find the area, we're going to take our radius squared times pi. So that would be 7 squared times pi, and most of the time we'll be leaving our answer in terms of pi. So our answer would be 49 pi units. To find our circumference, we're going to do 2 times our radius, so 2 times 7 times pi, so that would give us 14 pi. This is how you find the area and the circumference of a circle. The next skill we're going to look at is finding the arc length. In this example, the arc length would be the measure from A to B. So arc length is a portion of the circumference. So note, the arc length measures the distance from A to B, while arc measure is the angle formed. So we will actually need the measure of this angle to complete this length calculation. So what we would need is the measure of the angle, which I labeled as x. So we need to know how many degrees is from here to here. Divide that by 360. So that would be the fraction of the circle that is entirely covered. So that central angle divided by 360 tells you what fraction of the circumference we actually want to find. And then that fraction multiplied by the circumference would give us that distance. So let's try an example. Find the arc length of the following sectors. So remember, the entire circle is circumference. We just want a portion of that. So in this example, we want from A to B. So we want to figure out what is that central angle, and in our picture that's given at 120 degrees. So to fill out our formula, we'd have 120 degrees out of 360. That tells us the fraction of the circle that we want. Then if we multiply that by the total circumference, 2 pi, our radius is given at 6, that will give us our arc length. So our total circumference is 12 pi. So if we take 120 degrees out of 36, that gives us 4 pi. Rounding that to the nearest 3 decimal places, 12.566. Again, you should pause the video and try working this math on your calculator to confirm that you can do these. The next question has a different central angle and a different radius. Again, we're trying to find the arc length. So how long is that if we measured it with a piece of string and then we used it on a ruler to figure out the distance? So we want our central angle. So in this case, AB is really a CD, and that measurement is the same as its central angle. So we're looking at 60 total degrees out of 360, which is really a 6. So if we take a sixth of the circumference, 2 pi times 7, we get a fraction in there. So if you do a 6 times 14, that gives you 2 1/3. Or you could write it as 7/3 pi if you did an improper fraction, and rounding that to 3 decimal places would be 7.330. Again, that is meters. So our label would be meters because it's its length. If we go back to letter A, that would have been centimeters. Let's find the length of arc XY. Keep your answer in terms of pi. So again, our formula is the measure of the arc divided by 360 times our circumference. So we need to find the measure of the arc first, and then we also need to plug in the radius. So we have 2 unknowns. So we're looking for the measure of this arc, and this marking tells us that it is 90 degrees. So we have 90 out of a total 360. Our radius, we have to figure out. We were given a diameter of 16, so our radius is going to be 8. So 2 pi times 8. So this fraction we can reduce, which turns into a fourth. 2 times 8 is 16. So a fourth of 16 turns into 4. So the measure of that arc, or the length of that arc, is 4 pi, and our label would be inches. The next arc, it says find the arc length of XPY. So notice how there's 3 letters in there. That tells us that this is going to be a major arc. So X to P to Y. Major arcs measure more than 180 degrees. So notice how this central angle is not given on the inside of the circle, it's given out here. So that arc measure is 240 degrees out of 360. And then if we take that times our whole circumference, 2 pi times 15. So again, you should be pausing the video to make sure that you can get this calculation on your calculator. So 240 out of 36 is really 2/3. 2 times 15 is 30. So we're getting 20 pi. So when we're doing these calculations, we're doing all the green numbers except for pi to just get that lead coefficient. Our label for our radius is given at 15 in centimeters, so our answer will be in centimeters. So the skill we just assessed was learning how to find the length of an arc. The next thing we're going to do is find the area of a sector. So a sector of a circle is a region bounded by an arc, so here's our arc, and by the 2 radii. So it's like a slice of pizza. We'll be able to find the area of a slice of pizza. So our formula looks a lot the same. A lot like our length of our sector, or the measure of our arc. So the measure of AB is going to be, again, this central angle, and we will also need the radius. So now our formula is the fraction of the circle times the area. So let's find the area of each of these sectors. So our first circle has a radius of 15 and our central angle is 71. So we're plugging the 71 above the 360 degrees. So 71 out of 360 degrees. That tells us what fraction of the circle is actually shaded. The next part of the formula tells us what the area of the entire circle is. So our radius is 15. So one line of work to show us what we're doing. And let's round these to 3 decimal places. So again, confirm this answer on your calculator. We're not going to leave it in terms of pi. 139.408. The next question. Again, we want to find the area of the shaded sector. So our central angle is given at 149. So we want 149 degrees out of a total of 360. Taking that times the area formula, so our radius is 12. So 12 squared pi. Take a couple seconds, throw that on your calculator. 187.239. Label would be meters. Label on the first one was centimeters. Try number 3, pause the video, and then when you're ready, restart it so you can check your answer. So on this sector, the measure of our central angle is 40 degrees, so 40 out of 360, and our radius is 35.2 centimeters. Plug and chug, and we get 432.507 centimeters. What is the area of sector GPH? Notice how this sector is named. G to P to H. So it's naming that angle, and then that would also include this arc interior. So find your answer in terms of pi. So because it's a sector, we want the area formula. So just like the last question we did. So we want 72 degrees out of a total of 360 times the entire area. So that's 15 squared pi. If we leave this in terms of pi, we get 45 pi. And our label would be centimeters. Question 2. Pause the video and try this one on your own. The portion of the circle we're talking about is 45 out of 360. I drew an example just to help me visualize. We're trying to find the area of this shaded sector. So we want 45 out of 360 times the entire area of the circle, and that'll give us the pizza slice 2 pi inches. This concludes my video on area of a sector of a circle and arc length.